I'm Minnis Joannides, Chief Medical Director at Optimum Reinsurance, and this is the Optimum Academy, Ketamine 101, video number 3. How does ketamine actually work? So let's get started. So we talked about how do we achieve tranquility, going from perplexed to tranquility, and we talked about both measures we can do individually in our own life to help us lead a more tranquil life, versus medications, which are sometimes used for people that have depression or other psychological impairments. So we did mention previously in the videos that current antidepressant drugs have a significant delay in the onset of therapeutic action. It can be weeks to months. Approximately 1/3 of patients with major depressive disorder, MDD, fail to demonstrate an adequate response to these medications. And with these medications, either SSRI or SNRI drugs, there does not appear to be any significant synaptogenesis or formation of new synapses or improved neuroplasticity. So what else can be done to treat people with depression or other psychological impairments? So we talked about ketamine, a drug that has been previously used as an anesthetic for surgical procedures in both humans and animals in veterinary medicine. But now a new use has been found to treat depression. And this is kind of the basic idea of how it works. We talked about this in the last video. The ketamine, when given, appears to have an effect that blocks one neuron's effect in the process, where the black X's in the right-sided picture, and therefore more glutamate can be released into the synapse to get an excitatory effect. So ketamine works on the glutamate system, whereas serotonin works in a completely different system. So those SSRI drugs increase serotonin levels in the synapse. Ketamine increases the amount of glutamate in the system. So it has a unique profile that we mentioned in the last video. It has a slow off rate, meaning it has a prolonged blockade. And in the third bullet, it appears to improve or enhance increased remodeling and synaptoplasticity or synaptogenesis, so creating new connections in the brain, generating sustained antidepressant effects. And it's all due to this release of glutamate. And that has an effect on these AMPA or AMPA receptors. I mentioned that the speed of ketamine is much faster than SSRIs. It's kind of like the difference between taking a jet from New York City to San Francisco or going by bike from New York City to San Francisco, which could take you weeks to months. So we're going to talk about glutamate, the main excitatory neurotransmitter in the brain, facilitating propagation and transmission of nerve signals between nerves. It's essential for learning and memory and allows for neuroplasticity, or this new remodeling and how the brain actually works in a better way. It influences the growth and development of neurons, and through these actions, it helps regulate mood. So abnormalities in the glutamate activity can be linked to psychological conditions. So it certainly has a different looking structure than serotonin, which is the SSRI type drug reuptake inhibitors to provide more serotonin in the synapse. Glutamate has a completely different looking structure. Those gray dots in the structure are carbon atoms, and you can see that there's certainly a different formation of the molecule. And where have we heard about glutamate before? So glutamate is also used in food preparation. Monosodium glutamate is MSG, which you've heard of, and that's in accent formulation, which is sold in grocery stores. to enhance food flavors. Glutamate that we eat does not pass through the blood-brain barrier. So even if you eat a lot of accent, you're not necessarily going to increase the amount of glutamate in your synapses, but just kind of an interesting situation here that glutamate is actually the ingredient in an accent to enhance flavor, but we're talking about glutamate as an important neuroexcitatory molecule. So this glutamate, it basically affects and allows an improved synaptogenesis, or creating new synapses, and neuroplasticity by having its effect on the brain. And we're going to talk a little bit about how that works. And this is the AMPA receptor that glutamate actually has an effect on to allow this activity to occur. So you can see that when glutamate is active, it hits the AMPA receptor, causes a cascade, and that, through a lot of very complicated effects, causes increased synapses to be developed. And you can see how those new little bulges there, or dendritic spines, are produced by the glutamate cascade. And this is from the Awakenings Infusion Center site that provided this information. So, how ketamine improves synaptic connections with neuroplasticity. Ketamine treatments result in increased levels of glutamate. This is thought to occur by the blockade of the NMDA receptors, which turns off the suppression of glutamate, so it allows more glutamate to be released. And then the downstream glutamate cascade stimulates postsynaptic AMPA receptors and causes the expression of synaptic proteins and rapid induction of dendritic spines, so more connections can be formulated. And it basically allows a remodeling of things, or synaptic plasticity, and improves the function. And this happens in a very rapid way, so much faster than the SSRI or SNRI drugs. So there's multiple areas of action. As we talked about the NMDA and AMPA receptor activation, there's other complicated activity pathways that are also involved in this process. And both synaptogenesis and neuroplasticity can be effects of using ketamine. So this is a very positive, and can be a very positive effect from using ketamine to treat depression and other psychological impairments. The antidepressant effects of a single dose of ketamine is generally not sustained beyond 1 week. So when it's used as an antidepressant, it's not necessarily going to be longer than a week. Some people require more frequent administration of the drug, but it does appear to work very quickly and can have maintenance antidepressant efficacy over time. So each person is obviously different, and the medication may have different lengths of improvement in symptoms depending on the person. So the dose-related dissociative effects in anesthetic versus antidepressant use. And we talked about this in one of the prior videos, that ketamine can have a dissociative effect. What does that mean? It means a feeling of an out-of-body experience. So instead of you walking down a street in New York City with tall buildings on either side of you, it's as if you're standing still and the buildings are walking past you. So that's kind of, you get that difference in effect of, in some people, this can be a scary situation. So dissociative effects are considered adverse. Some people have these more than others, and so this is one of the downsides of using ketamine. If we looked at number 2, dose-dependent effects, antidepressant doses of ketamine are much less than the anesthetic doses that are used in surgery. So a smaller amount is given, whereas in anesthetic doses, they're usually much higher, and in veterinary medicine, they're even higher than that. So that's why when used as an antidepressant, the dissociative effects can be noted because a lower dose is being used, so the person isn't being knocked out for surgery with a large dose. So the dissociative effects actually occur because a smaller amount of medication is being used to treat depression than if you were getting surgery and being knocked out for surgery. Also noted, as this is a mistake here, but also the second bullet number 2, receptor occupancy. What is that? So at lower antidepressant doses, ketamine partially occupies NMDA receptors. This partial blockade leads to disinhibition of the glutamate neurons. In other words, it allows the activity of glutamate neurons because they're not being inhibited anymore. So this allows increased glutamate to be released and neural activity to take place in the brain regions. Bullet number 3 is dissociative effects are thought to occur at these lower doses due to the partial blockade and subsequent glutamate surge. These effects are often described as feeling detached from one's bodies or surroundings. And then the anesthetic action at higher doses when used for anesthesia, ketamine more completely blocks the NMDA receptors, and this widespread blockade results in general suppression of neural activity leading to anesthesia. So there's no chance for this dissociative effect to occur. So that's the difference between anesthetic and antidepressant doses. And you can see the different doses that are being used. For antidepressant use, 0.5 milligrams per kilo over 40 minutes, whereas for anesthetic doses, 1 to 4.5 milligrams per kilo, so a much higher dose. So that's the difference between antidepressant and anesthetic doses. These differences in dosing and administration contribute to the distinct effects observed with ketamine when used for depression versus anesthesia, Now I just wanted to show you, this is the number of ketamine clinics, which at the time I took this snapshot of the locale in the New York tri-state area. You can see how many ketamine clinics have already popped up because this is obviously being successfully utilized for some people. It's not for everyone. It has to be used under controlled conditions with the right therapeutic situation. It's often used, ketamine is often used in conjunction with, visits to a therapist, as well as possibly oral SSRI or SNRI medications as well. So this is something to be used under controlled conditions only, and not to be used in an illicit fashion when used for depression. So this isn't for home treatment or to be used in any way other than very controlled situations. So that completes our third video on ketamine. Look for other videos on other topics in the Optimum Academy.